and then all, and then just saying command copy for the Mac. It's probably control for the, it is control for the Windows machine. So I'm going to go down to my Arduino IDE and just click on it and have it open up for me. So, and I can always minimize this screen. I know that you can't see me, and that's okay. But you can see the Arduino board, and I really kind of want to maintain that view. See if I can turn it up like so. It probably won't stay like that. Let me see here. I just want you guys to be able to see the lights when it's cutting on or when I'm installing things. All right, hopefully that'll work. Okay, so you guys will see that I have a raw voltage. I have something that's called raw voltage here, but any two ways, let's just do a new sketch. And I'm just going to close the other one. So this is how you get your new sketches in. So you'll see, I'm not really concerned about all this code. This is pretty much the general setup. And so I'm just pasting in the information that I received, that I got off the Veneer website. So now, since that is done, I think they're going to upload. All of those are installed. Okay. So since that is done, I want to save this. Now, I typically save everything on Dropbox because I do work on this computer and then I'll go home and I want to do the same work at home, and you know, it's just like that. And so I'm going to go ahead and say, let me create a folder here, new folder, and I'm just going to say current and magnetic. Well, current probe. Let's start off with current probe. How about that? Current probe 2. Okay, and I'll call my sketch raw count because that's what we're going to look at. Oh, it didn't like that. So if I went, you'll see that they put that little underscore there. So it does. It says the sketch name had to be modified. The sketch names can only consist of ASCII characters and numbers, but cannot start with a number. They should also be less than 64 characters long. So I don't think that I can increase the size of this. And that is okay too, because I can always stop the share for this one and then go back to share and then say, let me share just this particular app. So I can make this a bit bigger, even though the writing isn't bigger, okay? So now this sketch reads the raw count from a Veneer analog BTA sensor once every half second, converts it to voltage, and prints both values to the serial monitor. So plug the sensor into the analog 2 port on the Veneer Arduino interface shield or into the analog proto board adapter wired to the Arduino pin A2. And so you'll see that we have this float raw count. This basically creates a variable, a global variable for reading from the AD converter, and that's going to be between 0 and 1. I mean 0 and 1023, and then float voltage, create a global variable for voltage between 0 and 5 volts. So the 0 is going to correspond to the 0, the 5 is going to correspond to the 1023, and we just have those numbers of divisions between there for those digital readouts for the analog to digital conversion. And we have our serial begin. So we're at 9600 baud. That's what the Arduino does, set us communications to the display. And then we have our raw count analog read. So we're reading A2. But if you notice, well, we'll start there. We're just going to read from A2 first. And then we have our voltage. It says raw count. And that's here. So we're going to eliminate this equation eventually and come up with our own. And then you have serial print raw count. So basically it's printing to the serial port. And then they have this tab in between it. And then they say serial print. And this line is like a new line for the voltage. And then you have print voltage and skip to the next line. So I guess I could have been reading this, but it says print raw count. And then it says print a tab character. And then we have our delay here. This is our wait a half a second. So if we had 1,000 here, it would be 1 second. But as it stands, it's 500 milliseconds. So this would be 500 milliseconds. All right. So what I want to do is I'm going to go ahead and select on this button right here. This button is saying verify. So we want to verify that all of the code is written right. And you'll see down here it says compiling the sketch. When you see this white writing, this is excellent. Okay, that means you're good. And then we're going to send this over to the board. So we're going to upload this to the board. So once I select on this upload, I want you to look at the board. You should see some lights going on and off. Oh, now look at what happens. It says problem uploading to board. So it's basically saying overdue, serial open, cannot open device. What is this? Device, CU, USB modem 1411, no such file or directory, problem uploading to the board. All right, so this is what we have to do. We need to go to tools. And so you really can't see what I'm doing, but tools are at the top. In fact, so then I should share that part. Why not? Share the entire screen. So now when we go to Arduino, we need to go to tools here. And once you go to tools, you'll see port. And right now it is not selecting this port. So this is the port that we want to select. We're going to go ahead and select on that. And now that we've selected on that, let's go ahead and try to do this again. I'm just going to push. You see those lights go off? And look at this down here. It says sketch uses 11% of the program storage space. So 3,550 bytes, okay, of program space. So what in the world is a byte? Let's see if we can go and find out what a byte is. So I'm talking all of this stuff. Byte. So byte, I'll go to Wikipedia. So the byte is a unit of digital information that most commonly consists of 8 bits. So that's the primary thing that I'm interested in. If I go to, what's a bit then? A bit, it's a binary digit. It is a basic unit of information used in computing and digital communications. A binary digit can have only one of 2 values and may be physically represented with a 2-state device. These state values are most commonly represented as either 0 or 1. All right, so that's your bit, and this is your byte, and your byte consists of 8 bits, okay? And so they had some more. So let me see right here. The size of the byte has historically been hardware dependent, and no definitive standards exist that mandate the size. And so byte size is from 1 to 48 bits. All right, are known to have been used in the past. All right, so the modern de facto of 8 bits is documented by, let's go here. I'm just going to open this in a different one. 1993 is a convenient power of 2, permitting the values 0 through 255 for 1 byte. Okay. Okay, let me go up here and look at this. So, I guess we could keep getting deeper and deeper, but I hadn't really looked so deep into that. I really thought that the byte was was defined a little bit differently than that, even though I understood that. So let me go. Let me see if I can guess some things here. So we have 8. So if I do 2 to the power of 8, what do we get? 256. Okay. So if I do 2 to the power of 8, it's 256. So if you go up here and you look at this, it says 0 through 255 for 1 byte. That is 1. 0 is 1, and then we have 255. So that's pretty much 256. Okay. Interesting. Man. Okay. So the C and C++ programming languages define 1 byte as an addressable unit of data storage large enough to hold any member of the basic character set of the execution environment. The C standard requires the integral data type to be unsigned character, must hold at least 256 different values, and is represented by at least 8 bits. So this is kind of like letting you know some things here. Okay. All right. Enough of that. Again, I wanted to see it a little bit differently, but let me see if I can find anything about how bits work or bytes work. Okay. Well, enough of that. I may have to cut all of that out of the video, but I did want to kind of like bring that into play. So, but we can read this data from 0 to 1023. There's a correspondence to the actual byte or bits there. And it's something about, I want to say that it's something, if I just did ×4 here, you'll see that we're getting 1024. And so with this 1024, if you look at this, it has 0 to 123. If you have the same kind of thinking, you have 0, which is 1, and then we have 1024. So we're able to read between there. This is the conversion that's going to take place. All right. So when I do that, I can hit this serial monitor. And with the serial monitor, you will see that data is being collected. Even though we don't have anything on this particular device, you'll see that data is being collected. So the first, let me see. Yeah, the first number is the raw count, and then the second number is the interpreted voltage. So if you look here, let me pull that back up. If you look right here, we have our raw count, that's here, and then we have our voltage reading, that's here. So these are the things that are being printed out. Okay, I'm hoping that that helps. I'm going to stop right here, and I'll hook up. Well, I'm just going to stop right here.